Okay, now we're in the exercise 2 section of the notes. And the materials are basically a rehash of Wells's material, examples, and exercises. So just to emphasize that to you, this is what they look like. There's going to be, each section is going to say materials for certain exercises. There'll be contents, there'll be examples, and there'll be exercises. All right? What are we going to do? We're going to do the examples. All right? So my impression over here is when you're doing these things over here, certainly I'm going to just, calmly scroll through the notes. And I'm looking at it, multiplication of algebraic expression. I just kind of scan it. We're not expecting to read this as I scan through it, but they talk about all kinds of things. And Wells is detailed. He talks about a lot of stuff. And you might say it's annoying how much he talks about things. There's some new words over here you might be seeing. Homogeneity. Again, the whole point of reading is you're going to see new things, and you might be confused by those, but you continue to read anyway. He talked about concepts like detached coefficients. Not a bad concept. Maybe you should read through that too as well, and we do recommend it. We do recommend it. Again, as you read this stuff, you may say to yourself, I'm not sure why I need to use these words. They come out later on, and the more experience you have with the better. So what I want to do is I want to go through the work as I would go through the work in any classroom. All right, so I would do examples at the board, and I'll tell you what. This one, I start slow with it. It says they want me to multiply. Well, the nice thing about multiplication, it's commutative. I'll write this down. Now again, Wells is of the opinion that this should be done by inspection, but I'll tell you about what goes in my mind. In my mind, what I do is I move things around, and that's what's known as I'm going to use a commutative property. That multiplication is commutative. The order in which I put it down doesn't much matter. As I commute things around, I like to put the numbers with the numbers and the letters with the letters in alphabetical order. And then I do my multiplication. How do I do that? I associate things that behave well together. For example, the 7 and the minus 2 as a multiplication behaves well, it's minus 14. And the AB is just simply AB. Look at the key, and you got that down. All right, now I'm going to do the next one. As I do that, I am going to actually write down the process by doing the commutation immediately. So what do I see? The numbers first, minus 2. I see 6, and I see minus 7. I'm going to write the letters in alphabetical order. That's A squared. I see another A, and I see an A4. Again, Wells is of the opinion that this should not be written down. B cubed. I'm just writing the B's now. B5. And I got a C, right? What do you get over there? Well, let's do the numbers first. And certainly what I mean by that, I'll point out what I'm looking at. I'm looking at these numbers here. And I think I can multiply it together. Like minus 2 times 6 is minus 12. And minus 12 times minus 7 is a positive number. It would give me 70 plus 14, which is 84. I'll write that down for you. Now I'm looking at the next group. I'll point out what I mean by that, the A's. And basically it's just a counting problem for me. There's 2 factors of A followed by 1 factor. Now there's 3 factors followed by 4 factors, so there's 7 factors of A. And then the B's, what am I looking at? Well, there's 3 factors followed by 5 factors. That would be 8 factors of B. And then there's a C. And I'm going to say that's my answer. I'm committing to it by putting a box on it. But I want to look at Wells's answer and see if he got the right answer. And what did he get? He got 84, A7, B8, C. Okay? What do I type up for you? And what my work would look like if I were explaining it in the classroom to students. All right? Let's take a look at the next one. Again, not bad. I'm going to be writing this thing left to right. I like to put the numbers down first. And what numbers do I see? Minus 5. I see a minus 8. Again, Wells claims that you shouldn't be writing this stuff down. You should just be doing it. That's A cubed and an A and a B cubed. And I kind of agree with Wells on that writing things down can be really cumbersome. You can make a mistake and just copying, get dizzy by copying too. So it's going to be 40. I'm associating the minus 5 with the minus 8 as multiplication. A4. There's 3 factors followed by 1 factor. And then B, which is 1 factor followed by 3 factor, is B4. I'm seeing it. All right, let's do this one over here. Now there's, three factors. I'll write them down for you. It's 4n squared minus 3n5 and 2n4. Again, I'm with Wells on this. I think writing it down really doesn't help me much. I'm going to do the multiplication, though. And what would you get? Well, 4 times minus 3 is minus 12, and minus 12 times 2 is minus 24. I'm sorry, excuse me. I'm going to do the n's now. So I have 2 factors of n, followed by 5 factors of n. That's 7 factors now. Followed by 4 factors. That's 11 factors. Yeah, it's nice to have an answer. We're in agreement. All right, this is a little more abstract, but I'm seeing a factor, minus 1. I'm seeing a factor of x to the nth power. That means there's m factors of x. I'm seeing a factor of 7, and then 6 factors of x. So, minus 1 times 7, I'm doing the multiplication now, is minus 7. And if you have m factors followed by 6 factors of x, you would have m plus 6. That's done. All right, a little more complicated. I'm seeing it. And I'm seeing terms here. And I'll tell you what I mean by that. This is a term. This term has 2 factors in it. The factor of 6 and a factor of m plus n. Now that factor of m plus n occurs 4 times in that term. But look at this one over here. I'm seeing a factor of 7 and a factor of m plus n, but that factor occurs 3 times. So what I'm going to do? I'm going to multiply just by looking at it. 6 times 7, 42. And I see a factor of m plus n. I do see 4 followed by 3, and there's 7 of them. No, you're not going to do anything with that except write it down. All right, let's look at this one, a little more complicated. They want me to multiply this trinomial by this monomial. I'm going to write that down for you now. And I like to write it in a particular way. I like to write it as a small guy first. I see one term as being smaller, or monomial, times that trinomial, which is 2x squared minus 5x plus 7. The way we're going to do this, we're going to take this thing here and distribute it across the 3 terms. Again, you don't have to put the arrows in. I'm saying what I'm doing over here. So the first term would be minus 8 times 2 is minus 16. X cubed followed by x squared. Well, 3 followed by 2 would be 5 factors of x. Next would be plus. Reason being is you got minus 8 times minus 5 is plus 40. 3 factors followed by 1 factor is 4 factors. Next up, you got minus 8 times 7, which could be minus 56, and you only got the factor of x cubed there. So I'm going to put a box on it indicating that's my answer. I make mistakes all the time. Let's take a look at their answer and see if we can agree with it. And I do see that, I see that, and I see that. And I'm going to move forward now. Let's look at number 8. I'm going to write it down for you. This is a binomial, 3a minus 4b times a binomial, which is 2a minus 5b. I'm going to multiply. Now, I'm going to do that. It's this 3a distributed across those 2 terms. Sorry, I forgot to close parentheses out. And then this term here distributed across these 2 terms. All right? I'm going to erase the arrows because I really don't like writing them down. But I do know some students like to put arrows in and tell you what they're doing. You don't have to. I'm just going to do the multiplication now. What do you get? 3a times 2a is 6a squared. Then we get 3a times minus 5b, that's minus 15ab. Then you get minus, 4 times 2 is 8, and then you get ba. We'll talk about that in a second. Last but not least, you get that last term, which would be plus 20b squared. All right? Now, I'm going to write a little bit differently. I'll tell you the reason for that. I really like to write things in alphabetical order, like AB. All right? Now, you realize multiplication is commutative, so what would this be? This is the same thing as 8AB. Now, I'm not saying you need to do that. I'm just saying a lot of students may want to do that, because what do they now notice? Those 2 internal terms are like terms. They have an identical variable part. Well, let's do that now. What do you get? 6a squared minus 15 minus 8 is minus 23ab plus 20b squared. I'll put a circle on it, indicating that's my answer. I'll look at their answer and see if I got it right. I got the first term, I got the second term, and third term. Okay, so Wells is also the opinion that you should look at that and write the answer down quickly. Yeah, you'll get there. But if you're not there, you know what? The more time and effort you put into this, the more you're going to see how easy it is to multiply a binomial times a binomial. All right, this one's a little more difficult. I'll tell you why it's more difficult. It's this, and I'll outline it for you. It's this expression here, which has 1, 2, 3, 4 terms in it. That's a 4-term polynomial times a 2-term polynomial. Well, I'm going to write down, and I like to put the small guy first. And the small guy is 2x plus a. What do you mean by small? It's only 2 terms. And then this really long guy over here, it's nightmarish for me. I'll write it down for you, though. And minus 8x cubed minus 2a squared x. Well, let's see if I can do it. And I'm going to distribute the 2x across those 4 terms. What do you get? 4a x cubed. Let's go to the next term. Plus 2, I like to be in alphabetical order, by the way, a cubed x. Let's go to the next term. Minus 16 x4. And I'm distributing the 2x, that's all I'm doing. Minus 4a squared x squared. Now we're going to distribute the a across those 4 terms. And what would you get? Well, let's see, you get 4a squared x squared. Well, you know there's a guy just like that over here. Then what do you get? You get a4. There's no a4, so I'm going to write that over here. Then what do you get? Minus 8a x cubed. And where is that? I think I made a mistake copying somewhere. Let me take a look and see if I multiplied correctly. First of all, 4. I see it now. 2 times 4 is 8. Sorry about that. Someone says, how'd you know you made an error? I hate to tell you this. I'm looking at the answer key. And that's bad news for me. I shouldn't have done that. But I looked at it and said, this is not working out like I wanted to. So I made a mistake. Maybe I made another mistake too. But let me keep going through that. And again, someone says I lost track of what you were doing. Well, I did the a times the 4a x squared. I got that. And I did the a times the a cubed. Now I'm doing a times the minus 8 x cubed. What would you get? Minus 8a x cubed. And last but not least, you're going to do the a times minus 2a squared, which is going to be minus 2a cubed x. A little line over here. I'm going to add things together. What happens? This disappears, this disappears, this disappears. And what are you left off with? Well, what you're left off with is minus 16x4 plus a4. There's nothing wrong with this answer. But I do want to write a little differently as a4 minus 16x4. They're both the same answer. All right? So let me go to the next page. And I'll write this one down for you again. And again, it really does look bizarre. And I'll write down for you what I'm seeing. I'm seeing x minus a times x squared minus ax minus bx minus ab. Let's multiply it out. You're going to get x cubed. I'm distributing the x across the 4 terms. Minus ax squared minus bx squared minus, that's a square by the way, sorry about that, abx. Right, this is done. Let's do the next one. What do you get? You would get minus ax squared. Let's see what you get next. Minus, let's see, I can be careful here, right? That's going to be not minus, plus, right? A squared x plus abx And last but not least, you get plus a squared b. All right? Now, guys, it may look strange to you, but I'm kind of, looking at this and saying it's all over the place. I do see x cubed, though. And again, this may seem strange to you, but what I'm going to do, I'm going to look at this. These are all the squares. These are like terms. I'm going to add that together, and I'll be very careful to do that for you. So plus minus 2a minus b x squared. Now I'm going to look at this. These are the terms with just an x in it. Well, I notice something nice happens. This disappears. And we're left off with plus a squared x. And then you get plus a squared b. All right. I'm going to circle and say, and that's a fine answer as far as I'm concerned. But I realize some students, they look at the answer key, and they look at it and say, oh, you got it wrong. Well, I'm definitely seeing the x cubed. I'm definitely seeing the a squared x, and I'm seeing this. Now, someone look at this and say, oh, I think you got that wrong. Well, what they did, which is not a bad idea, by the way, I'm saying it's just not a bad idea, they factored out the minus sign, or the minus 1. And what would they get? Minus 2a plus b x squared. But don't think one's better than the other. It's not. They're both the same answer. So if you're confused when you're doing the problem sets, think about it. And if you need help, reach out to your mentor or reach out to me. Okay? We did okay on that. Let's do the next one. And I'll write down for you. And that's going to be x minus m times x plus n. And I'll take a look. Let's multiply it out. What do you get? X squared plus xn. I'm going to write it as nx though, okay? And then I'm going to get minus mx. And then I'm going to get minus mn. And I got to be honest with you, to me this is a good looking answer. But Wells does something. He looks at the two internal terms and says, hey, they can have them together. So he gets x squared plus n minus m. He's adding your coefficients together, minus mn. Both answers look good to me, and I do have both answers listed here for you. All right, they're both the same answer, by the way. Now, some people like one answer over another. I kind of appreciate what Wells does. He kind of like writes it in a form where maybe this will become a pattern later. All right, more difficult now, and I really do mean that. This multiplication for a lot of students is way more difficult. This is a trinomial times a trinomial. Let me write it down for you, though. So 3x squared plus 5x minus 4 times 2x squared minus 7x plus 1. Now, there's going to be, a lot of multiplications here, and let's just go through it. And I'm going to distribute the 3x squared across the three terms, 2x squared minus 7x plus 1, one at a time. So what do you get? 6x4 minus 21x cubed plus 3x squared. This is done. Now we're going to do 5x. 5x times 2x is 10x cubed. So I'm lining things up. And then you're going to get minus 35x squared. And then you're going to get plus 5x. This is done. Now I'm going to do minus 4. What do you get? Minus 8x squared. Let's see, plus 28x minus 4. I'm going to put a little line over here. I'm going to add them together. And what would you get? 6x4. I'm going to add the cubes together. I'm pointing out what the cubes are. These are the cubes. When I say that, I mean the x cubes. That would give you minus 11. I'm going to add the squares together. You may wonder why I'm using the term add. I'm adding their coefficients. And that would give me what? Looks like minus 40, right? We'll look at the key later. I'm going to do this. And that would give me 33. What's nice about having a key, you have immediate feedback if you're getting it right or wrong. 6x4 minus 11x cubed minus 40x squared plus 33x minus 4. Now, some people might say, well, what if your answer key is wrong and I don't agree with it? Reach out to me. Let me know what's wrong, or let me know you think it's wrong, okay? Let me keep going. Getting better. And I'll write this one down for you, and it's 2a squared minus 3x squared. That's a binomial. And the other guy's a trinomial. And it kind of looked nightmarish to me, a lot of bookkeeping. The other problem is sometimes I copy things wrong, and then I wonder what happened. Generally, I just simply erase and try again. Let me write it down for you, and I'll be careful. 2a squared times 4a cubed is going to be 8a5 plus 2 times 6 is 12. A squared a is a cubed, and I get an x squared. 2a squared times minus 7x cubed is minus 14, and that would be a squared x cubed. All right, I just did the 2a squared. Now I'm going to do the minus 3x. What do you get? You're going to get minus 12 a cubed x squared. I'll write that down. Then what do I get? I would get, let's see, minus 18 ax4. Well, I have no other term like that, so I'll write that down. Minus 18 a x4. Then I'm going to do minus 3 times minus 7. That's 21 x5. Well, let's add it together. All right, you sort of like put a little line over here if you want. And what'd you get? 8a, whoops, sorry about that, 5. These disappear. Thank God for that. Minus 14 a squared x cubed minus 18 ax4 plus 21 x5. I'll circle it, indicating I'm done. But yeah, make mistakes. Let's take a look. I got the first term. I got the second term. I got the third term. And I got the last term. So I'm comfortable this is the correct answer. All right. All right, so this one has 3 things in it. What I mean by that, there are 3 factors. 1 factor, 2 factor, 3 factor. And I'm going to say if you're going to do that, I would say do 2 factors at a time. All right? And this is what Weslow was saying. Do it, but do it quickly. Get it over with. Inspect it and write it down. But I'm not at that stage yet. What's 2x times 3x? 6x squared. Then you're going to get 10x. I'm using the distributive multiplication for the first 2 factors. Then you get minus 9x, and you get minus 15. Now, the last but not least, I get the 6x minus 1. So what I want to do is I want to write it in a slightly different order now, where 6x minus 1 is the leading factor now. It's in front. And I'm going to simplify this part over here. What would that give me? 6x squared. 10x minus 9x is 1x. Minus 15. Now I'm going to multiply that out. What do you get? 36x cubed plus 6x squared minus 90x. I'm going to multiply the minus 1 across the terms. What do I get? Minus 6x squared. You notice I like to line things up, right? And then it would be, let's see, minus x. And minus 1 times minus 15 is plus 15. Put a little line there. Remind you what we're doing. We're combining the terms together. What do you get? 36 x cubed. This disappears. Minus 91x plus 15. Let's take a look. See if we got it right. I see that. I see that. I see that. Let's keep moving. And I'm done. So when I say I'm done, well, I'm done, but maybe not done. What you need to do is you need to do these exercises, all right? How many exercises are there? Well, if you kind of scroll through it, 1, 2, 3, 4, 5, 6. Wow, that's a lot of exercises. And a lot of people say, I'm not ready for that. Well, at some point in your life, you'll be ready for it. So the other one is because after you finish all that stuff over there, you really should start thinking about, how do modern machines deal with problems like this? And that's to do with the Sage code. What is Sage? It's a computer algebra system. That's called CAS. This Sage is free. It's available online. You go to this website over here. There's a download. You can download the application or web-based. I'm saying for most students, web-based application is fine at this point. But you know what? Maybe you could type this stuff in over here and see how it's working out for you, right? This has something to do with the problem set. And the problem, it looks like it's related to problem number 17. It actually looks like it's problem 17. And you may want to look back in that and see, how much struggles you had with 17 when you did it, and how really simple Sage sees that problem. Right? That I'm not going to say that's alarming to you, but that should be sort of like a saying that how did they program this stuff over here? And again, yes, the programmers that program Sage would certainly know how to do this thing by hand. They'd have to be able to program that. So don't think that this stuff is just some kind of magic they're doing. They had to know how to do that to perform those operations. All right. So I'm going to say, I'm hoping you're ready to work on this stuff over here, and maybe read over this section, maybe read over the examples again, and get through it. All right. What are we doing? Page by page by page to get to the end. Again, if you need to reach out to me, I'll remind you. My name is Ron Bannon, and my email address looks like that. It's BA, that's the @ symbol, NNON.US. But I want to just point out one thing. I call this the @ symbol. In other parts of the world, they call that a mouse. And I guess it looks like a mouse with a tail. All right? Whatever you call it's fine by me, but that's a symbol on your keyboard. I call it the @ symbol. All right? Okay, thanks for paying attention, and hopefully you're getting busy with the work. Thank you.